Hi everybody. Today we are following along with me on week 2, page 4 of 8 in your packet. So pull out your packet and that's what we're going to be doing today. So we are dealing with vocabulary for quadratics. We've been talking about this new shape called a parabola. So the shape of a quadratic equation is called a parabola. The standard form of a quadratic equation that looks a little bit different than linear exponential, it's going to be ax squared plus bx plus c. So this spot at the very bottom, sometimes it's the very top of a function if it's facing upside down, this is called our vertex. Parabolas are symmetric, so there is a line down the middle that cuts it exactly in half. We call this our axis of symmetry. When the vertex is at the highest point on the graph, we call that A, meaning like if it was facing upside down, it doesn't have a lowest point because it goes on forever, but it does have a highest point. We're going to call that our maximum point. And vice versa, when the vertex is at the lowest point on the graph, kind of like this picture right here, when it's facing upward, that lowest point is a minimum. The place where the output value is 0, meaning when y equals 0, that's our x-intercept. So right here I have an x-intercept, and right here I have an x-intercept. Sometimes we have 2 intercepts, like this example. Sometimes we only have 1 intercept, which an example of that would be like it goes down, touches, and then bounces away. So there's only one place where it touches the x-axis. Another example would be if it was kind of floating above or below the x-axis. For example, this one is never going to touch the x-axis. Or maybe if it's facing down the other way, it doesn't cross the x-axis, therefore we don't have any intercepts. All right, turn the page. Given the graph, identify the following. Starting with our axis of symmetry. Well, we've got a line that goes through the middle. This is a vertical line, which means it has no slope. So what originally would be y equals mx plus b, we can't do that because it has an undefined slope. So instead what we do is that since it's passing through the x-axis at 3, every point on this line has an x value of 3. So we're just going to call it x equals 3. A good way to remember how to do vertical and horizontal lines, do some little side notes. Hoi and VUX, hoi vux. Hoi stands for horizontal line. Horizontal lines with a 0 slope, and their equation looks like y equals some number. Vux stands for vertical lines, which has an undefined slope, and it looks like x equals some number. So hoi vux helps you figure out the equations for their lines. Since this was a vertical line, I'm using vux. It's passing through x equals 3, so x equals 3. My vertex is my highest or lowest point on the picture, which looks like it's right here. So I'm going to find that coordinate going 1, 2, 3, down 2. The y-intercept is where we think it's going to cross the y-axis. Now, it's not obvious on my picture yet, so I'm going to skip that one right now. If you look down here, we've got an x-intercept right here, which is at 2, 0. That's not my only x-intercept. I also have one right here, which is at 4, 0. The y-intercept is going to be a little bit more tricky. So we're trying to figure out what is happening on this picture. Where is it going to eventually hit? Well, it looks like it goes, let's build a table. We have a point at 2, 0, 3, -2, 4, 0. I want to move backwards to figure out what's happening at 0. So it looks like this point might be at 1, 6. Let's see if we can notice a pattern. Hope you can't see that. Sorry. This looks like it's minusing 6, minusing 2, plus 2. The pattern I see from there, it looks like it's adding 4 each time. So if it's adding 4 on its way down, if we want to move backwards, it would probably be a -10 because -10 plus 4 would give me -6. So moving back, what number -10 would give me 6 would be 16. So my y-intercept that matches with x = 0 is 0, 16. Domain and range. If you don't remember what domain and range mean, domain is the possible x values. Well, range is our possible y values. Oop, possible y values. So let's just talk about x values. In this graph, it goes off and forever both directions. So it's really going to be encompassing all the x values this way and all the x values that way. So if we're encompassing all the values, that's pretty much -infinity all the way to +infinity. Now we can't touch infinity, so we're going to put parentheses around it to tell the reader that it's never going to touch infinity, but it gets really close. The range is a little bit different. These are all the y values. So what's the lowest y value on the picture? Well, this has a minimum. If it has a minimum, the lowest y value looks like it's going to be a -2. But then the graph goes on forever upward, which is going to have a infinity follow. We already talked about how it's never going to touch infinity, so go ahead and put parentheses around that side. But it does touch y = -2. So because if it's going to touch that value, instead of parentheses, we're going to put brackets. And that's that. We're going to be doing number 9 and number 10 in class tomorrow, so don't worry about doing those right now. I'm going to post a video about writing our domain and range, so be sure to watch that before class tomorrow as well. All right, bye y'all.